Okay, we're going to rip into a few worked examples here of oxidation of alcohols using the examples that are in the textbook. Okay, so the first one we're going to look at is propan 1-ol being oxidized by permanganate ions. So let's write down here propan 1-ol, and we're going to use the MnO4- as our oxidizing agent. We'll get to that in a second, but let's focus on propan 1-ol. It is a primary alcohol. We have meth, eth, propan, H is our alcohol, and we have a H here. So it's a primary alcohol, which means it's going to oxidize to propanoic acid. Remember, if it's a secondary, it's only going to go to a ketone. So propanoic acid will be our end result. Now, before we write the equations and start putting in our electrons lost and gained, let's work out why and how these electrons have changed in the propan 1-ol molecule itself. So going back to year 11, you have oxidation rules for assigning numbers to or oxidation states to certain elements. And the ones we're going to focus on here are obviously hydrogen and oxygen, which are important in organic chem. And we're going to assign an oxidation state to the carbon that the hydroxyl group is attached to based on those rules. So we know that hydrogen in this case is a +1. There are exceptions to that, but really we don't care about that right now. It doesn't come into play in this situation. So we're just going to say +1 for hydrogen, so +1 here as well, because it's attached to the oxygen that's attached to our carbon. And we have a -2 oxidation state for the oxygen. So we can see here that for propan 2-ol, if we add up these oxidation states, we need to balance that and neutralize that, so to speak, with the oxidation state of carbon. So we can add these up and say we've got a +1, +2, +3, -2 is +1. So this must be a -1 oxidation state on that carbon in propan 1-ol. We don't worry about the carbons that are attached to carbon. They don't come into play. It's just hydrogen and oxygen that we're worried about that's going to influence that oxidation state of the carbon. Excuse me. Moving along, let's have a look at propanoic acid, which is what we're going to oxidize it to. Meth, eth, prop, and oic acid is our end result. Now, it's going to go to an aldehyde, then onto a propanoic acid, but we're going to do this in one go. Okay, so let's assign here, we've got 2- and 2- and +1. So you can see the hydroxyl here, OH, with the -2 and the +1 is always going to be like an overall -1. So if we add up our oxidation states here of what's attached to the carbon, we've got a -2 and a -2, which gives us -4, +1 gives us -3, so this must be a +3. The carbon here must have a +3 oxidation state to cancel out those other oxidation numbers. So let's have a look at what we've changed from and what we've changed to. So we've gone from a -1 oxidation state on that carbon to a +3. So how does that number increase by 4? Well, it must have lost 4 electrons. Remember, oxidation is loss of electrons. Oil reduction is gain. I don't know if you guys remember the oil rig acronym for oxidation, Redox. So in this case here, propan 1-ol, when we oxidize it, and we're going to use permanganate ion to do that, it's going to lose 4 electrons. And it does it in 2 stages. It loses 2 to get to the aldehyde, and you can go ahead and work that out like I've just done if you want to see how that works, assigning oxidation numbers, etc. But it's going to go to an aldehyde, lose the 2 electrons, then lose another 2 in another reaction to get itself to propanoic acid. We're just doing it in one jump. I'm just trying to make it a little bit easier. Don't want to spend too much time on this, so I'm just kind of speeding it up a little bit. But you could go ahead and step this out even further into the step 2 aldehyde to propanoic acid. However, the headline is the oxidation has lost 4 electrons. And unless you distill off the aldehyde, it's going to go to propanoic acid anyway. It's going to oxidize fully and lose the 4 electrons. All right, so that's one thing we're going to keep in mind. We're losing 4 electrons when we oxidize propan 1-ol. All right, let's have a look at our oxidizing agent. We have permanganate ion, and in your data sheet, you've got the half reactions for the reduction of permanganate ion and dichromate as well. So you don't have to remember these. It's actually in your data sheet that you get in the HSC and the trial. Go ahead and have a look at that now if you want. Go and find the half reactions, the redox reactions for the reduction of these two species, and you'll find them in there, so you don't have to remember it. There's only a couple of things you have to remember here. And really what I'm doing now is just stepping you through the background as to why, because it's awesome in chemistry just to understand why things happen rather than kind of accept it at face value. Granted, some things we do have to just accept at face value because we don't have all the time in the world to dig to the bottom of everything, but some things are good to know. Let's work out the reduction then of this permanganate ion, because remember, if something's losing electrons, then something's got to be gaining electrons in a redox reaction. And this is our oxidizing agent here. Okay, so let's go back to our oxidation numbers. We know that oxygen is -2, and we have 4 of them. So we can say that this is -2 times 4, which gives us an oxidation number here of -8 for those oxygen. Now we've got to equal -1. That's the overall charge on this ion here. So we can say that +7 minus 8 would give us our overall charge here of 1 minus, or -1. So in this case, the manganese atom here has a +7 oxidation state. Now, when that is reduced, it actually produces Mn2+. So from here, we're going from a +7 state. It gets reduced to a +2 state. So we've reduced that number from 7 to 2, hence the name reduction. So we've reduced it by 5, which means we've gained 5 electrons. So remember, reduction is gain of electrons, oxidation is loss. Excuse me. Okay, so if we're losing 4 electrons here and gaining 5 electrons there, that's not going to balance out. So we'll need to do the equation and take note of those, what's been gained and what's been lost, and do a little bit of balancing and work out our equation. That is just an overview of how we work out the oxidation states of the propan-1-ol, the propanoic acid, and the permanganate reduction as well. Just so you got a little bit of background as to why all of a sudden we're putting in 5 electrons and 4 electrons here. Well, that's the reason why. Let's move on and have a look at actually doing some of these equations. Okay, so let's oxidize our propan-1-ol with the permanganate ion. So let's write out our equation here and start with CH3, CH2, CH2OH, propan-1-ol. That is going to produce, we're going to go to propanoic acid, so CH3, CH2, COOH. Now remember from our accounting we did before, we know that that's also going to produce 4 electrons in that little oxidation there. Now we'll just do a little bit of balancing. We've got 2 oxygen on the right in our acid, and we've only got 1 in the alcohol. So to balance that up, we need to add a water. That's how we put some oxygen in here, by adding water. And now we're going to balance up our hydrogen. So let's have a look. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the right here, we've got 1, 2, 3, 4, 5, 6. So we need to add 4 hydrogen to balance out our hydrogen. So balancing oxygen, you need to add water, and then if you need to add some hydrogens to balance up H's, yep, go ahead and do that. So that's half reaction for the oxidation of that alcohol done. Now let's look at the reduction of the permanganate ion here. So Mn O4 minus, remember it gains 5 electrons, we've worked that out before, so plus 5E is going to produce Mn2 plus. And what else is it going to produce? Well, let's have a look and balance this up. We've got 4 oxygen on the left in the permanganate ion, so we need to add 4 H2O on the right here. So now we've taken care of our oxygen. We've also got to make sure that we've balanced up our hydrogen. So we've got 4 times 2 is 8 on the right. So we need plus 8H hydrogen on the left here, and that's balanced up now. So there's our 2 half reactions. Let's balance both of these together and then combine them into our final reaction. So looking at our electrons, that's where the issue is going to be. 4 electrons being lost by the alcohol, 5 being gained from the permanganate ion. So in order to balance that out, let's find a common number between them, which would be 20. So I'm going to say that I need 5 of everything on top then. 5 of those, 5 water, produces 5 of these, now producing 20 of those, and 20 H's as well. So 20 electrons, 20 H's. 4 times 5, so we're turning this into 4 of those. 4 times 5 gives us now 20 electrons. We're going to have 32 hydrogen now, 4 times 8. And we're going to have 4 Mn2 plus, and we're now going to have 16, 4 times 4, 16 H2O. Now we can combine these two and do a little bit of eliminating. So there's our 2 halves of the equation, and I'm not going to write these both out and combine them both before I do the elimination and cancelling. I'm just going to do that now. Excuse me. So let's have a look. We can cancel out 20 electrons from both sides. Excuse me. We've got 32 hydrogen here, and we've got 20 on the right. So get rid of that 20, and that gives us a total here of 12. 12 hydrogen. They can stay. We've got 5 water on the left and 16 on the right. So let's get rid of 5 here and get rid of 5 from there, and that gives us a total of 11 H2O. Our acid can stay, permanganate can stay, and our alcohol can stay. All right, now let's combine this guy together. Excuse me. And we're going to start with the alcohol. So 5CH3, CH2, OH, plus permanganate, so 4 MnO4 minus, plus our hydrogen, 12 H. It's going to produce, I'm going to run out of room here, 5CH3, CH2, OH, which is our acid. Hopefully I don't run out of room. 4 Mn2 plus, we might be okay. And our 11 water plus 11 H2O. And that's it. So that's our combined redox equation here for the oxidation of propan-1-ol. And now we're going to go and have a look at, what is our next one? I think it's pentan. Is it pentan-2-ol? I think we're doing a production of a ketone next. All right. All right, so here we go. We'll do the next example. We've got pentan-2-ol being oxidized by the dichromate ion. We're going to rip through this. You can watch this back. You can pause it. So I'm just going to go through fairly quickly and explain how we work this out. So let's start like we did last time by looking at oxidation states of the dichromate ion and our pentan-2-ol. Here we go. Pentan-2-ol meth eth prop but pent pentan-2-ol OH and a H, and we don't worry about the carbons attached to it when we're doing our oxidation state. So that's what we're interested in. The hydroxyl group, which is, remember, a 2 minus and a plus 1 gives us that hydroxyl group overall is a -1, and hydrogen is +1. So that gives us an oxidation state here of 0 on the carbon. Excuse me. Now, this is a secondary alcohol, so it's not going to go all the way and oxidize to a carboxylic acid. It's only going to produce a ketone. So we're going to produce pentan-2-one, because it's not on a terminal carbon. That's going to look like C. What's going on with my pen? It's doing funky things. C, meth eth prop but pent, pentan-2-one. All right, and that's a -2. We know that's for our oxygen, so that's fairly straightforward. We must have a +2 oxidation state on that carbon there, on the carbonyl functional group. Okay, so that's how we've assigned. Oh, and again, and then we can also just say, like we did before, we've lost 2 electrons in this case. So to get from alcohol to an aldehyde or a ketone, you're going to lose 2 electrons. An alcohol, a primary alcohol going all the way to carboxylic acid, like we just saw before, goes through 2 steps, which loses 2 electrons each time for a total of 4 electrons. So there we go. Pentan-2-ol, to become a ketone, has lost 2 electrons. So that's been oxidized. Oxidation is loss. And we need to do the rig, get your rig out, and we're going to do a reduction of dichromate, Cr2. Oh, I don't know why I said that, but anyway, it's been a long day. O7, 2 minus. we've got 7 oxygen, which gives us a total of, so 7 times a -2, we have -14. We've got to come up with an overall oxidation of 2- here, and we've got -14, so plus 12 minus 14 gives us -2. So the CR2 has a plus 12 oxidation state, which each of these CRs must be a plus 6 then, all right? So you should be looking at this as individual atoms, what their oxidation state is, and both of these are plus 6 for a total of plus 12. Now, we need to, well, that gets reduced down to CR3 plus, excuse me. Then we're going to have 2 of them to account for those. So CR2 gives us 2 CR3 plus. So overall, this 2Cr now has a plus 6 oxidation state because we have 2 CRs, each with a 3 plus. Whereas on the CR2, we had, again, 2 CRs, but they had a plus 6 oxidation state each. So we've gone from a plus 12 and we've reduced it down to a plus 6. So we have gained 6 electrons. And again, these don't balance out. We're losing 2 here and we're gaining 6 here when we reduce the dichromate ion. Excuse me. So like we did with our, what did we do, propan-1-ol just before, we need to take that into account when we do our balancing for our equations. So that is how we work out the oxidation state of the carbons within our organic molecules. And you can apply that little process we just did then to any of the situations you get yourself into or any of the questions. Feel free to write out a little structural formula and assign your little oxidation numbers and do some accounting and balancing and making sure that things check out. You'll work out, excuse me, how many electrons are lost in this oxidation. Remember that the reduction of the dichromate and the permanganate ion, it's in your formula book, so it tells you how many electrons are gained by each of those and those reductions, so you don't have to remember that, but it's good to be able to just work these out anyway. So there we go. We're going to gain 6 electrons with the reduction of the dichromate ion, and we're going to lose 2 electrons when we oxidize a secondary alcohol, pentan-2-ol, down to a ketone, which is pentan-2-one. Well, let's go ahead like we did before now and get into the equation. All right, last example. You may want to use the process we went through for the previous equation to see if you can have a go at this one, or you might want to just work through this one with me. But feel free to go back and do these again and run through it till you can do your balancing and accounting of excuse me, electrons, and you're comfortable doing it. So let's get stuck into this one here. I'm going to use molecular formula because we've increased the number of carbons to 5. It's going to get a little bit long to draw all of this out. So let's say we have, what do we do? Pentan-2-ol. So we're going to do C5, H11, OH is going to oxidize to C5, H10O, which is our pentan-2-one. And remember that that's lost 2 electrons during that little process there. So we've also lost that hydrogen and another hydrogen. So we've lost 2 hydrogens, so we're going to have to account for that over here and say we've also produced 2H, 2H plus. So that's our little half reaction there for the oxidation of our pentan-2-ol. Excuse me. Let's do dichromate. Cr2, O72 minus, and we know that it's going to be reduced by 6 electrons, and it's going to produce 2Cr3 plus, 2Cr3 plus. And what else do we need to do here? Oh, okay, so we've got 7 oxygen on the left here in the dichromate. We don't have any on the right, so again, we've got to add water if we need to add oxygen. So we need to add 7 H2O, and then we're just going to make sure that our hydrogen is balanced. So we've got 14 hydrogen on the right, 7 times 2, so we need 14 H plus on our left here, and that should all be balanced out. Now we can start combining these 2 half reactions together, but we've got to account for the charges here, the electrons, which are different. So this one should be not as bad as the one before. So we only have, look, we've got 6 electrons here. We've got 2 electrons being oxidized from the alcohol. So we can raise everything at the top here by 3. So that'll give us 6 electrons now. That'll give us 6 hydrogen, and we're going to have 3 of these and 3 of these. Now we can do a little bit of elimination. We can combine these 2 reactions, left and right hand side, and we're going to say that those 6 electrons cancel out with those 6 electrons. We've got 6 hydrogen cancelling out 6 of those, which gives us 8 hydrogen. 2 Cr we can leave. We've got no water on the left to balance or cancel on the right, so we're going to leave our 7H2O. We're going to leave that as it is. We're going to leave that as it is, and we're going to leave our dichromate ion as it is. So that was pretty straightforward. We can go ahead now and combine these 2 into 3 C5 H11 OH plus our Cr2 O7 2 minus plus our 8H plus. So that's everything from the left hand side here we've put into our combined equation, and that's going to produce 3 C5 H10O, so that's our pentan 2 own, plus our 2 Cr plus our 7 H2O, and that's our final equation here. So it wasn't as bad as doing the permanganate ion one before. There was less that we had to balance, but it was the same process. So practice this process here. Really, when you're looking at the oxidation of alcohols, you're going to be using dichromate or permanganate. Remember that those half reactions of the reduction of both of those are in your formula sheet, so you've got something to refer to. You've got somewhere to start. Even if you get into the HSC and all you can do is write the half reactions for some of these oxidations, if you can't get to the end result, just put down the half reactions, do what you can, and you never know. By the end of it, you might just keep balancing and saying, what do I do next? And you do the next step, and before you know it, you've solved it or you've completed it. But at least you know the half reactions are in your formula sheet. There's something for you to put down in your HSC if you get asked any of these full balanced equations for the oxidation of alcohol. So good luck with it. Hope this video's helped, and I'll see you guys soon.